I'm going to show you how to set the permissions for Linux systems on files and directories. First thing we need to do is take a look at what the permission set looks like and understand how to read the permissions of files. I am currently logged in as root on my Halverson Fedora Linux computer. I am going to type cd /. That will take me to the root of the file system and do an ls-l. And this will give me a directory listing of all of the files and mostly directories that exist on my system. What we're going to focus on is this portion right here. The first part of the listing will use this Morpheus directory that I created. I know that it's a directory because if I look at this first section of my directory listing, I see a D represented here. That D identifies that this is a directory. If it were a dash, it would identify it as a normal file. And we will see that example here in a minute. The next three identify a read, write, or execute permission set. That read, write, and execute are the only three permissions that you can set on a directory or a file. And those first set of read, write, and execute are applied to the user who owns that directory. So we have a user on this system named Beth who owns the Morpheus folder. Beth, the user and owner, has read, write, and execute. Read permissions allow Beth to see that directory and the contents of it. Write allows Beth to modify that directory and the contents of it, which also means deleting files or directories. And execute means that she's able to execute files that are scripts or programs. And a little caveat to that is that all directories need to be executable in order to open them and see the contents of them. So every directory that you see will have executable rights for the user or the group in order to make sure that it can be opened and the contents can be viewed. Again, read, write, execute. This first grouping of read, write, execute are assigned for this user who owns it. This is the owner of that file or directory. The next set of three, read, write, and execute, are for the group that owns this. So this Morpheus directory I have is owned by the Morpheus group. Beth is the user that owns it, but Morpheus is the group that owns it. And if you are a member, if your user account is a member of the Morpheus group, you have read and write access and execute access to the Morpheus directory. The last set of three is the other, meaning world or anybody. The other permissions aren't identified here because that's anybody that could connect to this computer remotely. That means through a web interface or through FTP or being a generic third variable on how permissions can be assigned on a system. We'll explore that later as well. So again, read, write, and execute are the three permissions. Now let's take a look how we assign those permissions, and we'll play around with this concept later as well. Read has a binary value of 4. I'm sorry, not binary value, but if we turn the read bit on, it can be either in an on state or off state. If it's turned on, it has a decimal value of 4. Write has a decimal value of 2, and execute has a decimal value of 1. So altogether, read, write, and execute add up 4 plus 2 plus 1 to the decimal value of 7. So any different variable options here, like this, for the other has a decimal value of 4. This directory has a decimal value of 5. Read has a value of 4. Execute has a value of 1. So 4 plus 1 equals 5. We'll play around with those numbers here later on. So let's get started. First thing I'm going to do is demonstrate how to create a directory. I'm going to create a directory on the root of the file system here called tank. Make directory tank. If I do a directory listing, I can see my tank directory by default, because I am root on this system. I own that file now, and that file's been put into my group. That folder has been given read, write, and execute permissions for the owner, which is me, root. The group has been given read and execute permissions. The group root, the only members in that group root are me, the root user. And then everybody, the world, or any other user on this computer can read that directory and go into it, open up that directory and see the contents. So, to test that theory, I'm going to log in as Bob on this system. I'm going to use SSH, Bob, and the IP address of that computer. Type in Bob's password and change directory, do an ls-l, and you can see Bob can see that there's a directory called tank, and he is now going to change directory into tank, cd space tank. So Bob can access the tank folder. Going back to the root user, I am now going to make a group called tank. So I'm going to do groupadd tank. So now my group tank exists. As a review, the tank group has been added to the etc group file. So if I cat the etc group file, I can see at the very end I have my tank group, and the group ID is 1012. So now that I've added the group tank, I want to add Bob to that group. So I'm going to do a usermod -g tank to identify the group, and the capital G identifies that I'm going to add the group tank to the user Bob. So now Bob has been added to the group tank. I'm going to take a look at the group etc group file, and you can see Bob is now a member of the tank group. So I am now going to set the permission on the group folder tank so the group tank owns the tank directory. And to do that, I'm going to use the chgroup command, and I'm going to identify tank as the group owning the tank directory. I'm going to do an ls-l, and I will see that the tank directory is now owned by the tank group. the tank group can read and execute. I am going to remove everyone from having access to this tank folder by removing these permissions. So only the tank members of the tank group will be able to see it and access it. To do that, I'm going to use that decimal value of the permissions. 4 for read, 2 for write, 1 for execute. So to do that, I'm going to use the command chmod, and I'm going to use the decimal value. So for the user root, it's going to be 7, and for the tank group, I'm going to set that to 7 as well. I'm going to give them, actually we'll leave it at 5. So 7, 5, and then 0. So 7, 5, 0 for the tank directory. ls-l, see what we did. So now any user on this system will not have access to go into the tank directory. But if you are a member of the tank group, which owns this folder, you will be able to read and execute the contents of this folder. And if you're root, of course, you'll be able to read, write, and execute. Now, a little caveat about root. Root ignores all permissions. Even if a folder or directory or a file has no permissions set on it, root will still be able to access all of those files and all of those directories. Let's test out what we just did. Now Bob I added to the tank group, which means Bob's going to need to disconnect from this computer and reconnect to get the new user settings that we just set up for him. So I'm going to type exit, Bob logs out, and I'm going to reconnect. Now Bob has read the new permissions and the new group ownership identification that we made changes for him, and now he should still be able to get into the tank folder. And here I am in the tank folder. I can access it. Do an ls-la, I can see all the contents of tank, and I can see it just fine. Let me log in as Tom now. Tom's another user. We haven't modified or messed around with Tom. So we're going to log in as Tom on my computer using SSH. And I'm going to change directory back to the root of my file system. Do an ls-l. And I can see the tank directory, but because I'm just the user Tom and I'm not in the group tank, I should not be able to get into the tank directory. Permission denied. So if I want Tom to have access to the tank directory, I have to add him to the tank group. Well, I'm upset as Tom, so I'm going to exit out. I don't have access what I need to. I'm going to talk to the root network administrator, or root administrator for this system, and say, add me to the group, please. So we're going to do a little modification. We're going to do a usermod -g tank for the user Tom. So now if Tom logs in, Tom should now be able to change directory to tank, just like Bob. Alright, so now let's take a look at some file permissions. Bob is going to create a script, and we're going to use the vi command, vir.dir.sh. What this will do is create a file called directory.sh in this directory. And just to test this, I'm going to hit I to insert, and I'm going to use the shebang /bin/bash. And I'm going to do a ls-l long listing and make it colorful. And when I do a shift:\wq, it says cannot open file for writing, meaning if we take a look, the group tank only has read and execute permissions. They cannot write files inside of that folder. So I am going to have to quit with an exclamation mark to get out and not make any changes. Here I am as the root user. I am now going to change the permissions. So we're going to do a chmod 770 for the tank directory. So now I should be able to go in as Bob and create my script. Shebang bin dash ls dash l dash dash color. And I was able to write and create that file. So now if I take a look, I'm the user Bob, and I'm happy that I have my shell created. Well, in order for a file to be executed, a script or a program needs to be executable. And if I take a look at the permissions of this file, it is not executable. So I need to change this file so it is executable for Bob, so he can execute this script. So to change this file, we do chmod, and we're going to make it 774. And again, that's 7 for the user, 7 for the group, and then leaving it only read access for everyone else. Whoops, I can't hit enter. I got to identify what I want to do this to. The directory shell. Now if I do a directory listing -l, ooh, it's now colorful because it's now executable. So to execute this script, I have to type // because I'm in the current folder, dir.sh. And what it does is an ls-l, just like we did before, but I executed the /dirsh. Now, let's go see what Tom can see. Tom's in the tank folder. Present working directory is tank, ls. We see the dir.sh. Well, Tom is pretty excited about this. He wants to be able to execute this script too. /dir.sh. Permission denied. Well, Tom is in the tank group, which means he has read, write, and access, or read, write, and execute to everything that's inside of it. Let's take a look here real quick. Bob is the one who created this file, so Bob owns it, and Bob's group is the one who created this file, so Bob's group owns it, which means that Tom can only read it. Well, let's take a look. Tom wants to see what's inside of this. Use cat dir.sh. Yep, I can read it. I'm Tom because I'm an other user having the other permissions. So what I have to do is do a chgroup, change the group ownership of this file to tank for the dir.sh file. Now, if I'm Tom, I should be able to execute it. And there I am, able to execute it. So we went through a few of the commands to make modifications to files, folders, and directories. We'll play around a little bit in the next video on modifying a sticky bit. So any files or folders that are created inside of the tank directory will stay owned by tank. So all the users of that group tank will be able to read, write, and execute files inside of the tank folder. Hope you enjoyed and understood a little bit more about file and directory permissions.